Hey you guys, Lissandro here, and today I'm gonna do a tutorial video, more kind of like a suggestive recommendation type of video, and I'm gonna focus on software. Now, for those of you who pretty much start off and software, and this is in reference to software engineer teams, programmer groups, coders, hobbyists, hackers, and so on. Um, so whatever language you're focusing on, whether it's C++, C Sharp, C, Objective C, Java, or any other programming language. One of the things you usually recommend to focus on is focus on your planning. And the reason why I'm focusing on this is because basically, and this usually goes to amateur programmers, script kiddies, hackers, and so on. And as a matter of fact, I used to do this, and what I used to do is pretty much um, there were like two crucial mistakes that I made, and not systematic mistakes like errors or anything like that. Yeah, I did that every now and then, but these were like two important steps, and one of them I just wrote the code. I didn't leave any comments or anything, and pretty much what my software engineering professor told me was that I was supposed to leave comments, and the reason why is that if I'm working in a team or anything, and I'm writing code and I'm supposed to leave some um, give insight on what what this particular block of code does. The other person is not going to know what it is. They're going to have to figure out on their own, and that's where you start possible mistakes, errors, glitches, and so on. And also, if I'm reviewing my own code and I come back, I may or may not remember what that particular block of code is. And that's something I'll focus on another video. But the second mistake I did was that pretty much I just started writing the code, and I didn't have a basic plan. I didn't plan things out. I just wanted to start writing the code and not plan things out, and that's just a big no no. Why? Because you're basically going along, and one is that if you manage to write the code without any problems, completely flawless, that's fine. However, one of the problems is if you're writing code for something that you're gonna eventually later on diagnose if it's gonna work or not, based on the situation. Let's say you're writing blocks of code for like Facebook or Google, and you don't know how much, if it's going to handle the mass amount of people that are going to be visiting the website, and all of a sudden it crashes or some error happens, you're not going to know where to go. And pretty much you're going to wait the time you earned, the time you didn't spend making plans is going to be way lot longer trying to figure out what's wrong, diagnosing pieces here and there, and then in the end, it becomes counterproductive. It becomes time consuming. And the other thing is that you essentially don't have a plan. You don't have a guideline to go where to diagnose where to figure out what's wrong. So in essence, you're pretty much fucked. And the thing is this one of the things that my software engineering professor told me was that you always supposed to pretty much plan things out, and if you can, plan things out on pen and paper. And I when you first told me that, I didn't understand it why you had to plan things out in paper, and later on it made a lot of sense, because if you make a mistake on paper, you can easily go back, erase it, or scratch it out, and correct it. And it's basically kind of like a rough draft, kind of making like a rough draft of your actual essay. The other tool he also told me to do is what they call a decision tree, which basically gets me to this particular tutorial. And basically, a decision tree is kind of like a diagram to follow through, like a certain process, a certain guidelines of what you're gonna do in code. And this is not strictly designated to just code. It could be various things like business plans, chemical process and process plans, automation, network structures, and the list goes on. And the way they call this is basically they use it for set of algorithms, and what algorithms are nothing more than a set of instructions. Now I know this kind of sounds like a word they only use in certain particular set of instructions for for encryptions, things like that. But it's not only designated to that. Yes, it's true that encryptions use certain algorithms. As a matter of fact, a variety of different things use different algorithms. And basically, the best way you can describe it, the best way you can describe algorithms in simple terms is simply like a set of instructions. The way I learned it is the example that was given to me was that they described it like a sandwich. If you want to know the algorithm to how to make a sandwich, you basically have to go buy all your ingredients at the store. Then you have them prepared. That's of course if you haven't put them in the fridge or anything. Have them prepared. Your mayonnaise, your loaves of bread, slices of bread, of course, that you're going to use from the loaf of bread. Mayonnaise, lettuce, sliced tomatoes, cheese, ham, and you go about that first. You put the mayonnaise, lettuce, tomato, then the cheese, then the ham, and everything. You get a clean plate. You put all your ingredients back in the refrigerator, how they were, and then you eat the sandwich. So what I basically did, I described what an algorithm is. Now, what I want to focus on this is this decision tree. Of course, what you do is go ahead, edit text. Of course, the first procedure, I don't want to call it process. Um, let's say I want to create a certain program which tells me uh, if the person's older than 18. So I would go something along the lines of, is this person older than 18? Okay, so basically I have this. So what do I do next? So what I do next, I put a decision. And if I have things correctly, so I have a decision. Okay. If the of course if the person is indeed older than 18, then And then pretty much it goes to another process. Okay. Of course, I'm kind of relatively new to this type of diagram, but in reality, um, I know how to set up these trees and everything. It's just the first time I'm using this type of software for this. Okay, but anyway, okay, there we go. So this is how basically how you use it. Okay, so you have this, and yes, and what your end result is if edit text, if he's older than 18, he therefore is um, this person is an adult. Almost forgot this. This person is an adult. Okay. However, if you have by chance it happens to not be older than 18, then what happens is this. Okay. Let me go ahead, connect it here. Okay, no. Um, you have another process here. Okay. Add a text, and this person is a minor. Okay, this person is a minor, and you can either pretty much have this process to go back to where it started. So let me get like three lines here. Okay. So sorry I'm kind of slow and a little bit sloppy on this, but like I said, this is the first time using this software. But as far as the decision trees goes, I know how to do them on paper and all. They're relatively simple. So I start with a program, and it asks me, is this person older than 18? And also, I forgot to mention, this usually tends to be your input, a binary type of input, yes or no. Okay, so is this person older than 18? You put your input, and you have two choices, yes or no. And if it's yes, then you end up with the conclusion that this is an adult. However, if it's no, then it comes out with the statement this is a minor, and it goes back, and it pretty much reiterates, and it's gonna be continuous till it finally gets to the decision of yes. So let's say in real life scenario, you had a person that wanted to, let's say, get into a particular place, and they go to this machine, or you older than 18, assuming they are honest, they'll say no, and let's say that they're only allowed in this particular place once a year. They'd like to try once a year. Of course, this is an unrealistic scenario, but it's the best example I can currently come up with right now. But the thing is that let's say they try to get in this place, and they only can try once a year. This person happens to be 16, and like I said, let's assume they're honest. They say no, is gonna continue to ask. And because they of course there's more procedures that you can put, like for example, considering that I just said that they're only allowed to try once a year, I could put like other processes like amounts of numbers tried. And but the point I'm trying to make, that every year they come and in the machine asks, are you older than 18? It'll say no, and they'll start over each year till finally they get to 18. And um, they'll they'll finally they'll finally say yes, and then it'll go to an adult. Of course, there's a little something here to consider also. Is this person older than 18? Okay, older than 18. They're 18. So by so because they're 18, they cannot be older than 18, so they have to wait one more year till they're 19. And of course, it's little details you have to watch out when you're constructing your programs. But like I said, one of the basic tools that you use to pretty much construct your softwares, to pretty much plan out your softwares, is decision tree. This is just an oversimplified decision tree. In actual softwares, they're gonna which are gonna be usually softwares that interact with a variety of people. There's a whole bunch of these boxes and the decision boxes, and it gets completely overcomplicated. And they have to include a variety of different algorithms for this particular type of thing. But anyway, I guess this will be all for now. Thank you guys for watching. Please like and subscribe, and I'll catch you guys next time. Bye.